All right, welcome back to computer science. So I'm going to start with a quick review of last class, and then we'll go forward from there. So last class, we started looking at Python, and we looked at some of the very basic commands that we can use inside of Python. We visited the site Repl, all right, which is what we're going to be using again today. Again, in Repl, you've got your file manager, which is where the files actually are. You have the editor, which is where we're writing our code. And then you have the console window where we got our output. And we also saw that we could write like little small lines of code. We wouldn't want to write a whole program in the console window, but we could do a quick line here or there to kind of test things out. We saw that different operations gave us results that sometimes we expected and sometimes we didn't expect. So we had the double division sign for integer division. We had the percent sign for remainders. We saw that text could repeat itself using multiplication. And we also saw that sometimes we would get strange results when we used floats. And again, that has to deal with how computers in binary represents decimal numbers. But we could get around that if we wanted to by rounding things. We saw that there are different functions that are built into Python. All right, so functions like absolute value, power. So this would be if you wanted to do an exponent. And then we saw there were other functions that are built into Python, but we had to specifically request them. All right, they aren't automatically included with the program because it would make the program run slower. But if you want them, you just have to tell Python to import them and say like, yeah, I need them. So even though it's going to take a little longer, let's import those functions so that we can use them. And that included things like square root and like the random number generator. Both of those, we needed the import statements up at the top if we were going to be able to use them inside of our code. All right, and then we talked about data types, how you could have integers, which basically means no decimals, floats, which is another way of saying decimals, and then strings, which is a sequence of characters. And strings are usually designated by their quotations. So we saw that if you put a number inside of quotes, that would turn it to a string. So this would be the string 787 as opposed to the number 787. All right, so again, built-in functions. Functions generally have input values, which is what you're passing in. They have a return value, which is usually the answer the function is sending back. And you can nest functions. So here we have a nested function where the return value from the power function becomes the input value to the square root function. So we can have these sort of cascading or nesting functions where one provides the answer that serves as the input for the next function. Then we did some of these hands-on activities where you got practice writing some basic Python code. And then we got to this idea of naming values. So instead of just doing straight calculations, basically creating names or labels for our values. So I could say something like x equals 12. And then from that point forward, anytime I use the letter X, the program will substitute in that 12. And I can do it with multiple. So here I had H equals 3, W equals H, print H times W. And it's not just numbers that can be assigned labels. I could assign a string of characters to a label. So now the label name has the string of characters SIENA or Sienna inside of it. And then if I say print name, it knows to print out the word Sienna because I didn't put name inside of quotes. If I had put quotes around name, then it would have said, oh, they just want to print out the string name. But by leaving off the quotes, it's saying, hey, that's a label. Let me see what's associated with that label, and then I'm going to print out the associated data that goes on with this name label. And then again, we saw the same thing like multiplying. We could repeat it over and over again. And then we just did a little tracing, and we said, all right, if x starts off at 5 and y starts off at 9, if I do x equals x plus 1, that's adding 1 to the 5, and then changing x, so now it associates to 6 as opposed to 5. It's storing that 6 inside of this variable or label x, Same thing with y here. It started off as 9, so 9 times 2 is 18. And then that is now what the label y is associated with, or if you think of it as a variable, the variable y now has the value 18. Same thing here, z is just doing the 18 plus 6. Down here, again, same idea, we're just using the power function. And this is where we left off, all right? This is the sort of the last thing that we did in class. So let's move forward and see what we have next. So Python naming rules. So this is just some rules that you have to follow when creating your labels or your variables. We're going to see that they're basically called variables inside of Python. They must start with a letter. So you could have a name, label, variable, what have you, that's my word and set it equal to the value cat, but you couldn't say one my word. You could do my word one. All right, so if you wanted to do my word one, that would be okay. I could say, oh, I'm going to create a variable that's my word one. That's perfectly acceptable. You can create variables that have numbers in them. You just can't have them start with a number. I could also have a one in the middle here. I could say my one word. That would also be fine as long as you're not starting it with a number. Second point, you can't use reserved words. So there are certain words that we know already have a meaning in Python. All right, the word print has meaning in Python. The word if has meaning in Python. The word for, F-O-R, has meaning in Python. So there are certain reserved words that we're not going to be able to use. All right, so I can't use print as a variable name. Could I use print one? Yeah, I could use print one. That's a different name, but I would just stay away from anything that's a reserved word. All right, it's just going to make your code more readable and less confusing. So anything that's a reserved word, and again, we'll learn these words as we go through the course. You don't need to memorize the list right now, but you might run into a problem where you try to create a label, it's a reserved word. Just know that you're not going to be able to do that. All right. Case matters, all right? That means it's case sensitive is usually what we say there, case sensitive. So age is not the same as age. I could have one letter, I could have one variable or label that's lowercase a. I could have a second one that's uppercase a, and those are considered different. So I could have both of those inside of my program, and they would recognize those as separate labels. Next, when you see the equal sign in Python, read it as figure out the value on the right, give it to the name on the left. All right. So sometimes kids are like, oh, equal sign. I can put things on either side of the equal sign. Not in Python and just about any other programming language. All right. A lot of times, instead of calling this the equal sign, we call it the assignment operator. So you're taking this 4 and you're assigning it to the variable size. If I tried to flip this and put the 4 on the left and size on the right, Python would give me an error. That would not work. So you always have to make sure that the label is on the left by itself, not part of some larger calculation. And the calculation or the number is always on the right-hand side. So again, this is going to do size times 30 and then assign it to this label total. And if I flip that around and tried to put it on the other side, I would get an error. So it's important that the label or the variable is always on the left-hand side by itself. Then you have the equal sign or the assignment operator, and then whatever you're placing inside of that variable is on the right-hand side. So here I'm placing the calculation into this variable. Here I'm placing the number 4 into this variable. And again, this last point, another word for a named value is a variable. All right, and I've been using the word variable for the last 5 minutes because it's force of habit. All right. Anytime going forward, I'm just going to refer to those as variables, not named values. But that's effectively what they are. They're just a label so that we can refer to a value that we've stored and want to hang on to in our program and use at some place going forward. So keeping all of this in mind, let's try another tracing exercise. So we have 2 programs here, 2 little mini programs. And what I would like you to do is trace these, all right? Follow the code, pay attention to what's being placed where, and then see if you can correctly determine the output. All right, so I'm going to give you a second here. Pause the video, give them a shot, and then when you come back, we'll actually go through and see what we came up with. All right, so I'm assuming that you've tried them at this point. So let me get my pen here. So I apologize for the messiness, but this is what happens when you're trying to write with a mouse. So A starts off being assigned the value -5, and B starts off being assigned the value 3. Okay? So that's where we start. Now, when we get to this next line, it's important to remember how the assignment operator works. This is taking the value B and assigning it to the letter A. So it's not putting A into B, it's putting B into A. So this would then get crossed out, and A is now going to have the value 3 inside of it. All right. This right here, B is being assigned the value 20. All right. So this is just going to basically cross out the 3 and put in a value of 20. X is A times B, and we now know that A is 3 and B is 20. So X is going to be 60. And then since the final line is printing out X, it's going to print out this number right here. So this would be our final output, would be this value of 60 over here. All right, so that's the first one. Now let's try the second one. All right, so A is being assigned the value -4. B is being assigned the value 2. And then C is being assigned the square root, the absolute value of A. So again, these are nested functions. So we're going to start on the inside, and we're going to say, all right, this absolute value function is getting a -4 passed into it because it's getting A, which is -4. So that -4 is going to become a +4. That +4 then becomes the input to this square root function. And the square root of 4 is 2. So C is going to have a value of 2 in it. Right? X is A times C. Now, I never changed A. Yes, I used A as part of this calculation, but I never changed it. I never assigned it a new value. So A is still -4. C is 2. So X is going to get the value -8. And that's the same value that we're then printing out on this last line here. So we're printing out a -8. So again, just giving you sort of a highlight of how we trace these out, how we follow them, how we interpret these equal signs to make sure that we're following which values are going where. All right. So next thing that we're going to talk about is making our own functions. So we just saw that there are certain functions built into Python. All right. There's the square root function. There's the POW or power function. There's the absolute value function. There's the random int function. All right. We can also create our own functions inside of Python that do whatever we want them to do. All right. So how do we make our own function? All right. We start with the word def. So again, there's one of those reserved words. So DEF. Then we come up with the name of the function. All right, so this is the name of our function in this little example here, age in secs for seconds, age in seconds. Then the name of the input values between the parentheses separated by commas. So that's a lot to take in there. We'll see more in a second, but this would be your input values. And if you have multiple input values, you separate them with commas. All right, when you're done with your input values, you close your parentheses, you hit a colon, and then the body or the code of your function has to be tabbed in. It has to be indented from underneath your definition. All right, Python doesn't use braces like a lot of other programming language. Instead, it works on indentation. And by indenting this code, it knows that you want it to be part of this function. All right, so this is just a quick outline. We're actually going to head over to Repl pretty soon and see how some of this can actually work out. So here's Repl. So if you haven't done it already, you're going to want to navigate over to Repl because we're going to write some functions on our own and just see how this all works for us. Okay, so when you're logging into Repl, remember to use the accounts that were given to you during class. So you can go to login here. You don't type the username and password into here. You still click on the sign in with Google, and then you should pick the account that we set up last time and that you logged in last time. So if it gives you a choice between like your regular school account and the new computer science account, you're going to want to use that computer science account. All right. If you click on sort of the hamburger looking item to the left and go to home, all right, you've got all of these different options here. If you go to My Repls, all right, you should be able to find the Repl that we started last time. So for most of you, you called it something like First Day or Python Intro or First Day Python or Python First Day, but it should look something like that. All right, so you're going to want to reopen that. And then if you've got code left over from last time, that's fine. You can either keep that in there or you can clear it out. Again, there's nothing very special about this code. You should have it written down on your notes. So feel free to leave it or feel free to just get rid of it. I'm going to get rid of mine. And instead, we're going to start writing our first function. Okay, so we're going to write, if you look at the slides here, oops, wrong slide, where were we? Why? Nope, let's click through it this way. All right, if we look at the slides here, it says in Repl main.py, write functions for each of the following. Load your functions by pressing the play button, and then test your functions by calling them in the console. Right, so this first one says write a function that accepts one input value, that is the age of a person in years, and have it print how old that person is in seconds. Hint, we just saw this one on the previous slide. Type it in and try it. So I'm going to go through it right now in the video, but you can also just look at your note packet and look at what's written on your note packet, because that's exactly what I'm about to talk through and explain. So if you go back to the previous slide, you'll have it in your note packet there. So we start with the word def, all right, for definition. I'm going to call this one age in secs for like seconds. Now, if you notice the way I type that, it's what's called camel case. And this is generally how programmers write their functions, where you start with a lowercase, and then every word that you use after that, you capitalize the first letter of it. So age is lowercase, but then in starts with a capital, and seconds or secs starts with a capital. Okay. Then I have a left parenthesis. This is where I provide my input values, or the information the function is going to need to run. So I'm going to call my input values years. That's a label that I'm giving it so that when I use it later on, it's attached to the word years. Then I'm going to have a colon, not a semicolon, but a regular colon. Then I'm going to hit enter. Notice that Repl kind of automatically indents for me, which is good because it needs to be indented. Python works off indentation. So if you don't indent, it's not going to realize that it's part of this function. Then I'm going to do my first calculation, and this is going to look a lot like the stuff we were doing before. So I'm going to create a label called seconds, or SECS. I'm going to say equal, or the assignment operator. So anything I put on the right is going to be assigned to the left. And I'm going to be saying years times 365. And again, notice how I'm putting spaces after and before each of my operators. Again, that's good practice. Times 24 times 60 times 60. So there's my calculation. It's now being stored under the label or in the variable SECS. All right. Then I'm going to hit enter. And I'm going to just format my output. So I'm going to say print. And then inside of quotes, I'm going to say you are. Right. Then I'm going to print the value in my variable. So there's no quotations. I'm just saying print the value in my variable. All right. And then I'm going to say print, and I'm going to finish this off and say seconds old, so that if somebody's reading my program, they understand what's going on. So again, this is the body of my program. This is the name for my input variable. This is my function name. So if I run this, what you're going to notice is that nothing actually happens over in my console window, because I've created a function in my program, but I've not actually used that function. I haven't called that function. I haven't told that function to run. So I'm actually going to run it from over in the console window. I'm going to use the name of the function. There's the name of the function. I'm going to do the left parenthesis, and I'm going to pass it a value. So let's pretend I was 20 years old. I'm going to pass it that value 20. So when I hit enter, the 20 is going to go in and be assigned to this input label or input variable years. And then anytime years is being used in my program, the value 20 is going to be sent to it, because that's what I passed in. So if I hit enter, it's going to tell me how many seconds I would be if I was 20 years old. If I call my function again, right, and I pass in a different value, let's say I was 100, you would see my age at 100 seconds old. Okay, so that's one of the reasons we write functions, is that if we write them and use these input variables, we can pass in values and use the same code on different values. All right, so that was the first one. All right, that was the one that we were basically just copying what was on the slide before that. So what I'm going to do is I'm going to do the second one with you. All right, and then 3, 4, and this should say 5. 3, 4, and 5, you're going to do on your own. All right, I'm going to provide the answers so that you can check and see if yours looks the same or different than mine. But I'm not going to go through them in this video. I want you to try them. I want you to try to figure them out. And then I'll give you the code so that you can compare what you came up with what I came up with. And we'll see, are they basically the same, or was there a mistake somewhere that we needed to fix? All right, so let's do the second one together, and then we'll go from there. So the second one says, where's the second one? All right, the second one says, modify your function above so that it takes a more precise age for input. Instead of expressing the age only in terms of years, express it with 2 inputs, the number of years and months. For example, if a person is 5.5 years old, the inputs would be 5 years and 6 months. Assume all months contain 30 days. All right, so I could modify the function that I have, but I think because we're just getting started, it's probably a good idea to just start a new function. So I'm going to hit enter a few times. I'm going to backspace to get rid of the indentation. And by getting rid of the indentation, Python recognizes that I'm no longer part of that original function. So I'm going to call this one def, and then I'm going to call it advanced age in seconds, or just SECS. All right. Now the problem says that this one is going to have 2 inputs. It's going to have the years. So I'm going to do that just like I did before. And then when I have a second input, I'm going to use a comma, space, and then I'm going to make my second input months. All right. So if you have multiple inputs, and you can have more than 1 or 2 or 3 or 4, you just separate them with commas. I have the colon, which tells me, all right, I'm now ready to actually start writing my body. All right, this is sort of my header. And now I'm going to go into the body. So I hit enter. All right, it automatically tabs over for me, and I want to keep that tab. And now I have to do sort of a new calculation. All right, so I could say, all right, seconds equals, and since I'm getting everything in terms of, I'm getting years and months, I want to get everything in terms of days. All right, so once I get everything in terms of days, I can then continue with the same calculation that I used up here. So I did, 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. All right, but this part has to change because now I have both years and months. And the problem told me I could simplify it and just say that, every month has 30 days. So I'm going to start with a parenthesis because I need to follow order of operations. And I'm going to say years times 365, which is the same as it always was. But then I'm going to add months times 30. And so this is going to get me my total days, years times 365 plus months times 30. Once I have my total days, I can continue on and I can say times 24 times 60 times 60. Now yours is probably all on one line. Mine's just going down to one line because I had to zoom in so that you'd be able to see it a little better. All right, so seconds equals years times 365 plus months times 30. This is basically getting me the total number of days that I'm working with, times 24 hours in a day, times 60 minutes in an hour, times 60 seconds in a minute. And then the rest is exactly the same. So I can do exactly what I did before. I can say print UR. I can say print and then use my label or my variable. Again, no quotes here because I don't want the word SECS. I want the variable SECS so that it prints out my value. And then I can print the phrase seconds old. Okay. So that's the end of my function. Again, if I hit run, nothing happens, all right? Because I haven't told either of these functions to run. I've created the code for them. They're all set up. But unless I tell them to run, nothing is actually going to happen. So age in seconds, that was my original function. I can still run that one, all right? It's still there. It's still part of my program. But now I have a second function that I can now run. So if I call advanced age in seconds, now this one is expecting two pieces of information. So if I say, oh, I'm 20 and 5 months, right? It will do that calculation and give me the appropriate answer. Now, functions are very specific about what they expect. So if I try to call age in seconds and I provide it with 100 and I provide it with a month, this is going to cause a problem because this function is only designed to receive one input. So when I run this, it's going to give me an error because it says takes one positional argument, but two were given. All right. It only is able to accept one input. So if I give it two, it doesn't know what to do with the second one and it causes an error. On the same token, if I go back to my advanced one, advanced age in seconds, all right, and I only give it one input when it's expecting two, I'm going to get a different error. This one says missing one required positional argument months. It's saying, hey, you gave me the years, you didn't give me a value for months. That's a problem. So when you set up your function, you're specifying the exact format that any call to that function, because that's what these are, calls to the function, you're specifying the format that those have to take. And if they don't take the right format, the function is not going to run. All right, you're going to get an error because this one, it was only expecting one item and I gave it two. This one was expecting two items and I only gave it one. And those are both going to cause problems for our program. All right, so there are 3 other activities for you to do. All right, one says add a function that accepts 2 input values that are the lengths of the base and height of a right triangle. It should print the length of the triangle's hypotenuse. All right, so again, that's using a squared plus b squared equals c squared. So you're going to be using the square root function. And don't forget to use the square root function. You have to have this line at the top of your code. So if you took that line out, you're going to need to make sure that you put it back in. Otherwise, you're not going to actually be able to use the square root function. Along the same line, this one says create a function called roll dice that takes no input values, have it print out 2 numbers that are random, that are a random roll of 2 6-sided dice. In other words, each time you call it, it should print out 2 different numbers. Be sure to use from RAM import. So you've got to make sure that you have that random import up at the top of your code. Otherwise, you're not actually going to be able to generate random numbers. And again, if you need to figure out how to generate random numbers, look back earlier in your notes. You'll see examples of how we generated random numbers. And then last but not least, generalize the function above so that it takes 1 input value, which is the number of sides the dice have. For example, if the input value is 12, then it should print a random roll of 2 12-sided dice. If the input value is 20, it should do 2 rolls of a 20-sided dice. So you should be able to provide any input value, and that basically determines the size of the dice. All right, so I want you to try these on your own. You're not going to learn Python unless you try and get your hands dirty and write code to see where you're making mistakes, where you're not making mistakes, what's working well, what's not working well. So try these on your own. All right, you do have the solutions, but don't just copy down the solutions. That's not going to help you. You need to try them on your own, and then we'll go from there. All right, so the video is just going to keep going, but I'm expecting you right now to pause it and try writing those 3 on your own, because you need to be able to do that. All right, the functions that we write are only going to get more complicated, so you've got to start with these and make sure that you get comfortable with them so that as we move forward, you have the basics down. All right, so moving on now, we're going to talk about using pictures inside of Repl. So most of the programs that we deal with, we've already talked about this, are going to be like media focused, either pictures, sound, audio, whatever. So I want to talk about how it's going to work when we're actually, interacting with those. Now, you should have an email from me that has a couple of files that you're going to need to download. So if you go to your email, you should have an email from me, and inside of that email, there should be a file that's jess.py and temple.jpg. So you're going to need both of those files. So you can download them right now if you haven't already, but you are going to want to download those to your computer. And assuming you've still got the default set up, which there isn't a reason you wouldn't, they should end up in your downloads folder. So if I go to my downloads folder, you're going to see that there's jess.py, there's temple.jpg. So there's both of those files that I just mentioned. Now, to get them into Repl, you have a couple of choices. All right. One choice is in this Repl program that we have open right now, you can either choose add file right here, click the plus add file. I'm sorry, not add file. That's if you want to create a new file. Click on the dots and choose upload file. All right, so the 3 dots here, choose upload file. And then you can navigate to your downloads folder, choose those files, and import them. The other option that you have is if you open up Windows Explorer and you highlight those files, so I have both of these files highlighted right now, I can drag them over into this window and it will upload them into my program. So now I have this file temple.jpg, and if I click on it, you'll see it in the editor window. And I have this file jess.py, which is going to give us access to the functions that we need to be able to manipulate and work with pictures. So there's a whole lot of code in here. You do not need to do anything with this code. And in fact, you don't want to change the code, because if you do, you could break some of the functions and then you won't actually be able to do what you need to do. So it says right here up at the top, do not modify any code in this file. That's not a joke. Do not modify any code in this file. All right, you're going to need to leave it as is if you want to be able to do everything that we're going to do in our program. So that's step one, is you've just got to add these files to your Repl project or your Repl. All right. So again, you can either drag them right into the browser, into this window, or if you click on these three dots, you can do upload file and add them to your project that way. All right. So once those are in there, we're going to go ahead back over to our main.py, because again, we're not going to write anything in here right now. Those are just going to kind of sit there so that we have access to them. All right, so let's go back to the presentation here. So drag picture files you want to work with under the files. That's what we just did. If you click on it, you can view it. So again, that's what we just did. You can also click on those dots to upload it directly. So either way is fine, whether you drag them in or whether you upload them. Either one is good. Now, when we want to use these picture functions, all right, and we are going to want to use these picture functions, it's what we're going to be doing. The top of our program is going to need this right here, from Jess import star, which is basically saying from that jess.py file that we added to our project, import all of the functions that are part of that file. So we did something similar for import random and import math. The only difference is we didn't need to include those files. All right, we didn't need to include the math.py file or the random.py file. Those are sort of built into the Python language because they get used so frequently. In contrast, this jess.py is something that we're using basically exclusively in this course. So we have to provide the file and say, all right, here's the file, jess.py. Now import all of the functions inside of that file so that we can use them in our file, main.py. All right, so what I'm going to do here is I'm going to go to the top and I'm going to add from jess import star. That's going to go and import all of the functions from this jess.py file into my program. And again, I didn't need a file for these two because they're part of the language. All right, we don't include them automatically because there's no need to, but they're part of the Python language, so we don't need to have that separate file in our project to actually import those. We can just import those automatically. If I tried to run this without actually having this file, it wouldn't work, all right, because it wouldn't know what Jess is. Jess isn't part of the Python language the same way random and math are. All right, so that's kind of phase one. Now, the first time you run this, when I hit run, I haven't written any code other than this line right here. You are going to see that it takes a little while to run. All right, and there's going to be some text that scrolls on the right-hand side here. This is it just getting all of the different files and dependencies and things like that that it needs to actually be able to use this jess.py and the functions that are installed in it. So just be aware that the first time you run this, when this file is included, it is going to take a little while. You're going to notice this says stop. Eventually it'll finish and you'll be good to go. And then it won't take as long after that. But the first time you're running the project, it is going to take a little longer just as it goes out and imports and gathers all the different pieces that it needs. Because you'll notice we're importing Jess, but if you click in this, Jess itself is importing a whole bunch of different things. So it just takes a little while for all of that to sort of be collected and managed before it'll actually run for you. Okay, so that's kind of phase one here. Now let's talk about some functions that we can actually use now that we've imported these things. So this first line right here, pic equals make picture temple.jpg. All right, so we've kind of talked about how we can have integers and we can have strings and we can have floats. So this jest.py is going to give us this ability to make almost like a variable. It's not quite a variable, but it's almost like a variable that's a picture. So instead of storing a word or a number, we're actually storing a picture. And we do that using this make picture function. So when we say make picture and then we give it the name of a file, that's creating that picture inside of a variable so that we can then do things with it in our program. So it's going to take this file and basically copy it into this variable pic so then we can manipulate it in our program. All right, add rect filled, again, is another function. All right, this is going to take this variable that we've created and draw a rectangle, and then write picture to is a function that creates a new file. All right, so this is actually going to create a file that we can then use inside of, that will then be outputted into our project. All right, so let's take a look at this for a second and see what these actually do. Okay, so I could write this code either in the console window or in the editor window. If I was going to do it in the console window, I would just type it in one line at a time, but I'm going to put it over here in the editor window and then have it run all at once instead of doing it like sort of one line at a time. So I'm going to start with pic equals make picture. Now again, all of this is case sensitive, so you have to make sure you have the capitalization right, otherwise it won't work. And then in quotes, temple.jpg. Now again, this is only going to work because I've already added this picture to my project. All right, if this picture wasn't in my project, this line would not work, but because the picture is in my project, we're going to be okay here. All right, so pic equals make picture temple.jpg. And now pic is basically a variable that I can refer to in other places in my code. And when I refer to it, I'm going to be, referring to a picture as opposed to a number or text. Right? Then I'm going to do add rect filled. Again, make sure you're paying attention to the capitals, capital R, capital F. Now this is another function that requires 6 different inputs. So the first one is where I'm going to create this rectangle. So I'm going to create the rectangle inside of picture. Then I have to decide where I'm going to create this rectangle. So we'll talk about these numbers in a little bit, but right now I'm just going to write 209, 161. Then I have to specify the size of the rectangle. Again, we'll talk about these in a second. And then I'm going to specify the color of the rectangle. All right, and I'm going to use red. And red is a reserved word for us. It's not a Python reserved word, but if you look in jest.py, you're going to see that red is a reserved word now. So here's red, and you're going to notice that, just like we learned in data representation, red, green, blue. So the color red is just defined as having 255 for red and then 0 for green and blue. All right, but anyways, we've got our 209, our 161, our 40, our 175. We're going to hit enter, and then we're going to write our last line, which is going to actually create our new file. So I'm going to say write picture to, again, paying attention to caps, left parentheses, pic, comma, output dot JPEG. All right. So when I hit play, these functions aren't going to do anything because I didn't call them. These are the ones from earlier. So if you've got yours in there from earlier, it's fine. They're not going to run. It's just going to run this code right here because this code is not part of any function. All right. It's not indented. It's not under one of these def headings. So it's just going to run this code. I hit run. You're not going to actually notice anything happen over here in the console window because we didn't tell anything to happen. All right. But what you should notice is on the left-hand side, you now have a new file called output.jpg. And if I click on this, you're going to see what our code did. All right. It basically drew this red rectangle on top of one of the columns that was part of the original picture. And if you look at the original picture, it's unchanged. All right, so here's my original picture. Nothing's different about it. And then if I look at my output picture, it now has this red rectangle here. So again, going back to this, when I do this pick equals make picture, pick is no longer the original file. So when I alter pick, I'm altering the variable pick that I have in the program's memory. I'm not altering the original temple.jpg file. So I can make all of these changes. I can write those changes to a new file, and my original temple.jpg has not been impacted at all because it was really a copy of that file that I saved sort of into this pick variable. So when I'm changing it, I'm changing that copy that I made. I'm not changing the original file, temple.jpg. All right, so this is just like a really quick sort of introduction to, Python and pictures. You're going to be doing a lab after this that goes into a lot more detail. And then as we go through this quarter, as we go through next quarter, we're just going to go deeper and deeper and see all the different things we can do inside of Python to like modify and alter and work with pictures. And what you're going to see is we're going to be writing code for a lot of the stuff that you would see in like a Photoshop program. So, Photoshop has code that's making all this stuff happen. We're going to learn how to write some of that code so that you have a better appreciation and understanding for a lot of what happens in a program like Photoshop. So going back to this for a second, just what are these picture functions doing? So we've talked about this a little bit, but pick equals make picture. This reads the file temple.jpg. All right, so this would be your input value is the original file, and then it returns basically a copy of that file that's now saved in this variable pick so that you can use it in other places in your program. All right. Add rectangle fill changes a rectangle-shaped group of pixels in the image pick. Remember, a picture is just lots of individual pixels. So it goes to this coordinate, and we'll talk about the coordinate system in pictures in a second. And then it makes a rectangle that's 40 by 175, and all of the pixels in that rectangle are set to red. So we're basically going into the picture and we're changing those RGB values so that we're erasing what they used to be and instead just setting it red 255, green 0, blue 0 for those individual pixels that we have specified. And then again, I've already kind of mentioned this, but this just writes the variable pick, which is the variable pick, which is storing a picture. Whoa, I don't know what's happening there. The variable pick, which is storing a picture, we're saving that to the output file, output.jpg. All right, so that's what these three different lines do. All right. So last but not least, I just want to talk about the coordinate system quick. A picture you can basically think of as like a giant XY coordinate grid. The top left corner has the coordinates 0, 0. As you go to the right, X gets bigger. As you go down, Y gets bigger. So when we described our rectangle there, we used the coordinates 209, 161. So 209 basically means we're going over 209. So there's our over 209. And then we're going down 161. All right, so there's our 161. So when we start making this rectangle, the top left corner of the rectangle is at the coordinates 209, which is your X value, 161, which is your Y value. So again, that means we went right 209, we went down 161, and then the 40 was the width. So then we said, all right, make it 40 wide and make it 175 tall. So it's going down and making that 175 pixels tall. And again, the pixels are those individual like data points of color that we're just combining to make the picture overall. So again, we've got our X coordinate, we've got our Y coordinate, we've got our width, and we've got our height. And then the color is being specified right there. And really color is just changing those RGB values to whatever numbers we specified. All right, so that's sort of it for today. All right, this sort of walks you through an introduction to Python and pictures and everything else. Next class, we're going to be doing our first lab. All right, so there'll be a packet, there'll be instructions, there'll be some files, and you'll be kind of going through it and answering questions, and it'll walk you through some code. Some of it you'll have to figure out, some of it you'll just copy down what they tell you and then, you know, look at the output. But it'll be sort of our first sort of step into this world of labs, and it'll give you a better understanding of a lot of what we're going to do with pictures in this class and how we're going to modify them and the different things we'll be able to do. All right, so I hope this was helpful. Have a great day, and I will see you next week. All right, bye.